In this video, I would like us to look at some harder recurring decimals. When I say harder recurring decimals, I mean those decimals that have the recurring pattern moved a few digits to the right from the decimal point. Like in this example, 0.063 recurring. So as you can see, 63 recurring is just one decimal place away from the decimal point. And here's another example, 2.075 recurring. Compare with this number. It is just 10 times less than 20.75, and it was so nice and easy to solve these normal questions, right? I would like to remind you how we were solving them. We would say that let x be equal 0.63 recurring, and then since we have just two digits repeating, we would multiply by 100. Multiplying by 100 would move that recurring pattern two decimal places to the left. And then we would subtract x from 100x, and we would subtract 0.63 recurring from 63.63 recurring, and that would give us 99x on the left side and just 63 on the right side, because all those infinite number of 6 and 3's would go away. Alright, so then now we would divide 99x equals 63 by 99 both sides, and we'll get x equals 63 divided by 99. Then we would simplify and we should come to 7 over 11. Okay, now if you would look again back to the problem where I started from, you will notice that actually we could deal with this problem quite easily if we would multiply our original number by 10. See what happens. If our original number 0.063 recurring is x, then 10x would be 0.63 moved one decimal place to the left. So it would become 0.63 recurring, right? So now we don't have that problem, we just have 10x equals 0.63 recurring, but we know how to deal with this problem, right? So we would multiply by 100, and we would multiply by 100 both sides. 10x times 100 is 1000x, and it is equal to 63.63 recurring. Subtracting 10x, because 10x is much easier to use here, I have exactly 0.63 recurring, so when I subtract 10x, my 63 recurring part will go away. Alright, so I will have, on the left side, I will have 990x equals 263, and then I would divide by 990, and I will get, finally, after simplifying, I should get 7 over 110. Okay, so let's look at the second example and see whether you understand that the steps would be the same. Again, let's say x is 2.075 recurring, right? Multiplying by 10 moves the recurring pattern one decimal place closer to the decimal point. So I'm getting 10x equals 20.75 recurring. And now I deal with this recurring pattern in our usual way. We multiply by 100, we are getting 1000x equals 2075.75 recurring. And then subtract 10x equals 20.75 recurring. We are getting this fraction after simplification. Alright, and now the very final bit. There are sometimes questions in GCSE exams when they ask you to define to determine which fraction will give you terminating decimal and which fraction will give you not terminating decimal. And actually it's not that difficult to do without any calculator. If it's on non-calculator paper, you definitely shouldn't divide, because it might take quite a long time. So could you please look at this pattern and see what you notice from this pattern. 1 over 2 is 0.5, so it is terminating decimal, right? It terminates, it doesn't go forever. So look through this pattern and see whether you notice anything interesting that you can say definitely just by looking at the fraction which one terminates.